Dear friends, welcome back to Data Analytics Talks. This is our fifth session under Azure Data Engineer Learning Series. We know data is everywhere, and efficient and effective management of data is the key responsibility of any data engineer. In this video, we are going to focus on the data aspects of Microsoft Azure. We will try to understand the need of a cloud storage and the major cloud storage providers, and we will have an introduction to Azure Cloud Storage account. If you have the theoretical knowledge, feel free to skip this video and find my next video on how to create your first storage account. As I already mentioned, data is everywhere, and the data is also available in multiple formats. And I'm quite sure you have heard about structured data, semi-structured data, unstructured data, and other forms of data. Data engineers should have the fair understanding of data to handle them properly and effectively. So let's look into various formats, data formats. So look at my screen. It is showing a tabular data. It is a well-defined attributes. So a structured data is a data which conforms to a data model, has a well-defined structure, follows a consistent order, and can be easily accessed and used by a person or a computer program. The structured data is usually stored in a well-defined schema such as databases. Hope you all know about databases. There are numerous databases like Oracle, SQL, Cosmos, so many types of databases you can find. It is generally tabular with columns and rows that clearly defines its attribute. Look at this example. We have the clearly defined attributes like purchase ID, last name, first name, country, date of purchase, and so on. So how do you manage this structured data? There is a language called structured query language, otherwise we call it as SQL language, is often used to manage structured data stored in databases. So this is another type of data format which we call as semi-structured, which also has some structure but not like the one we have in tables. So semi-structured data is a form of structured data that does not obey the tabular structure of data models associated with relational databases or other form of data tables. But it contains tags or other markers to separate semantic elements and enforce hierarchies of records and fields within the data. Therefore, it is also known as self-describing structure. So in semi-structured data, the entities belong to the same class may have different attributes. So semi-structured data are increasingly occurring since the advent of internet, where full text documents and databases are not only the form of data anymore, and different applications need a medium for exchanging information. So in object-oriented databases, one often find semi-structured data. Then comes the unstructured data. Look at the screen. It neither looks something similar to structured or semi-structured. It is a data dump. It does not follow any structure. So unstructured data is information that does not follow a fixed format or schema. Unlike structured data that can be stored in tables or databases. So data can be managed as a relational data, and data also can come in the form of messages. So message is a communication sent by a sender to a receiver. A message is usually a byte with some metadata. It can be plain text or other. So data storage should be able to manage relational data, message data, and so on. So still we have more type of data. Let us go to that. We have audios and videos, and within audios we have different formats. Within videos we have multiple formats. And we have sensor data. As the IoT devices are increasing day by day and the accumulation of data is also increasing, the role of sensor data is also increasing. So what's the sensor data? The sensor data is the output of a device that detects and responds to some type of input from the physical environment. Take an example of human. We have a lot of sensor information being generated. We have the blood pressure sensors. We have pulse oximetry sensors. We have ECG sensor. We have inertial sensor. All these data being collected, processed, analyzed, and arrives at some decision. It is helping our doctors. Okay, it is generated from multiple devices. See, the process of accumulation is too complex in this case. Data storage should support sensor data. Equally important is time series data. So what is a time series? In mathematics, a time series is a series of data points indexed in time order. Most commonly, a time series is a sequence taken at successive equally spaced point in time. It could be milliseconds, it could be seconds, it could be minutes, hours, whatever it is. So time series data is gathered, stored, visualized, and analyzed for various purposes across various domains. We have a session on CDF, Cognate Data Fusion, where industry manages their time series data for insight generation. So now we have been talking about data. Now this time for big data. I'm sure everybody has some idea about what is big data. When data arrives in a large volume and speed, it becomes big data. The three V's, volume, velocity, and variety, are three defining properties or dimensions of big data. So volume refers to the amount of data, velocity refers to the speed of data processing, and variety refers to the number of types of data. So as a data engineer, we understand data is everywhere, and this accumulated data has some power. It enables data analysis. Coined with the data science and machine learning, it can create insight that helps inform decisions. So as data engineers, we need to build a system to collect data to enable the best use of it. So while accumulating the data, we need to look into various aspects like data storage, data processing, and data visualization. So today we are focusing on data storage. Where do we store this data? What are the challenges? These questions we need to answer today. So when we want to store data, we store them on local storage devices. That is a normal process. So we have hard disk, we have flash storage, we have tape, we have desktop, laptop. All these are local storage options. But as the volume is increasing, as the need for faster processing, will this local storage suffice? That's the question. So local storage have many drawbacks. In the modern age, that's where we are resorting to cloud storage. So in the cloud storage, we are able to store videos, musics, documents, files, contacts, and pictures, and a lot more. And we are able to store and share. So there are many consumer-oriented public cloud providers. They offer free online storage with a capacity limit. Users can upload documents, photos, videos without paying until they exceed the capacity limit. The size of the files that can be uploaded may be capped, but users can purchase unlimited storage in the cloud if their budget allows. This requires buying capacity on demand as the need arises or paying a normal monthly subscription fees. Some of the examples, we have the Google Drive, Amazon Cloud Drive, OneDrive, Dropbox, iCloud, and Box. They are all examples of consumer storage providers. They support both Windows and Android devices, so enabling users to create, edit, share documents across devices. Along with the consumer storage providers, we have enterprise cloud storage providers. They provide both public and private cloud storages. So Amazon Web Service is the leading public cloud provider ahead of Microsoft Azure and Google Cloud. So Amazon S3 has aided in the rise of object storage, which presents data as unique object with a flat address. Other cloud storages providers with an enterprise focus include Alibaba Cloud, IBM Cloud, Oracle Cloud Infrastructure, and Rackspace. So the immediate question is, how do you measure the efficiency of the storage account? It is measured in terms of availability, reliability, scalability, elasticity, agility, cost savings, global reach, then pre-certified compliances, enhanced security, automation, environmental sustainability. All these are contributing to the efficiency of any storage capacity, storage. So considering all this, we are going to look into or concentrate into Azure Storage Platform. What Azure Storage Platform is offering in terms of these characters. So Azure Storage Platform is Microsoft Cloud Storage solution for modern data storage scenarios. Azure Storage offers highly available, massively scalable, durable, and secure storage for a variety of data objects in the cloud. The Azure Storage data objects are accessible from anywhere in the world over HTTP, HTTPS via a REST API. It offers SQL databases, which is relational. It offers table storage, which is NoSQL or key value pair. It offers blob storage, which is unstructured files. Then we have the infrastructure as a service called SQL Server, MySQL, Postgres, then MongoDB, Redis, and so on. Whatever the data format we have been seeing are supported in Microsoft Azure Storage Platform, and also gives you libraries for developing or building applications or services with .NET, Java, Python, JavaScript, C++, and Go. Developers and IT professionals can use Azure PowerShell, Azure CLI to write script for data management and configuration tasks. Azure Storage Platform comes with a lot of properties. It has access control, RBAC, role-based access control, IAM, then virtual network and firewall. It has encryption. It has secure transfer required. It needs shared access signature. It has access keys, advanced threat protection. It has cores. The storage account has container and has the blob storage options. And it is created within resource group, location, and it support local replication and geo replication. It has a hierarchical namespace, which is again supporting the data like Gen 2. We will cover that later. Then better performance, that has account kind, then default access tier, lifecycle management, Azure Search, CDN endpoint, custom domain, then it has also soft delete. So these are some of the Azure Storage account properties. We will see that in detail in some of the coming sessions. And if you look at the Azure Storage architecture, you can see that it has a queue storage, table storage, blob storage, file storage. We checked what is queue storage. We also understood what is table storage, which is relational table storage, the blob storage, then file storage. Within blob, we have block blobs, append blobs, and page blobs. Then there is also a front-end layer. Azure Storage Platform includes the following data services: Azure Blobs, Azure Files, Azure Elastic SAN, then Azure Queues, Azure Tables, Azure Managed Disk. So we will try to see them, each of them, when we are creating your Azure Storage account. So with that, we are going to end this session, and the next session we are going to take up how to create our first Azure account. Please share your feedback as comments, and don't forget to like, share, and subscribe this channel. Thank you.